looking at the second part of our notes here for 2-2 algebra is the division piece here. So again, just like with that multiplication, the absolute first and most important thing is that your bases are the same. Again, must have same bases. So when I'm doing division, you might be able to put together the pattern, or you might remember it from last year. When we had multiplication of the same bases, we were able to add those exponents. Now, when we have division of those same bases, we're going to be able to subtract those exponents. Or what I like to do more often is actually just cancel them out. So that would be x to the a minus b. X to the top subtract bottom. Or just expand and cancel out. This is going to be the best thing that you do, is that expanding and canceling out. That's a kind of because you'll be able to see it, and it'll make sense as to why you're getting the answer you are and why things are staying on the top or the bottom of that fraction here. All right, so example 5. Y to the 5th divided by y to the 3rd. So if I'm looking at that just straight up with the rules, that would give me y to the 5 minus 3, which is y squared. Now, that is, all fine and dandy, but that's following a rule. That's not really understanding what's going on. So if I were to look at this and expand this, y to the 5th means y times y times y times y, 1, 2, 3, 4, 5, divided by y times y times y. Well, we know from years of math that y divided by y cancels out to be 1. So look what I have left. I have y times y left on the top of my fraction, and y times y is just y squared. So in most cases, you just need to ask yourself, is it worth getting the question wrong, or is it worth, taking a little bit of time and expanding it, especially if you're not a memorizer and you confuse the rules. All right, example 6. So this one, you might be jumping into expanding right away. I've got 8 on the top, 10 on the bottom, 1, 2, boom. But some of you might be realizing that I can't do any canceling here because the x and y's are not the same. Not the same bases there. So they cannot cancel. But despite all that, there is one thing I can do to this example that does simplify it a little bit. And that is dealing with that 8 divided by 10. You could pull that right into your calculator, and the only thing you need to do is make sure that you keep it a fraction. It needs to not be a decimal. Or you can just simplify that. I know that both of those numbers are divisible by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. So my final simplified answer would be 4x to the 3rd power divided by 5y to the 3rd power. So we couldn't simplify our exponents, but we could simplify the numbers. We needed to simplify the numbers, or more mathematically, the coefficients. Bloop. All right, so let's take a look at example 7. Okay, so here we definitely have stuff that we can be canceling because we have same bases. So I'm going to expand this one out. So we have 20 divided by 5, x times x times x times x. 1, 2, 3, 4, 5, 6. And so this is an important example where you're going to want to use this expansion rule because I don't want any negative exponents. Negative exponents are a big no-no. So 20 and 5 here are both divisible by 5. So I'm going to do that. That leaves me with 4 on the top and 1 on the bottom, which I don't really need to write, but I will just for sake of the visual. And then I can do some canceling. X divided by X. Oop, that was really bad. Boom, boom. X divided by X, X divided by X, X divided by X. I'm left with 2 X's, but careful here because notice the placement of those 2 X's. Those 2 X's are on the bottom of that fraction. So I need to leave them on the bottom of that fraction. So this final answer is 4 on the top with X squared on the bottom of that fraction there. I'm just going to rewrite that. 4 divided by X squared. Okay, let's try this one more time. There we go. Okay. And last final example is this example 8. Similar to example 7, but a lot more complicated because there's a lot more pieces going on here. So let's take a look-see. Ooh, this time my coefficients, my numbers, have exponents to them. So 4 being squared, I know 4 squared is just 16, so I'm going to just turn that into 16. 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16. And again, you can just be putting 2 caret 4 into your calculator to be getting that answer. X, 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 Y. And now careful here, because even though that Y is technically next to that Z, that Y does not have an exponent of 3. Only the Z piece does there. We decided that 2 to the 4th power was also 16. 1, 2, 3, 4, 5 X's, another Y on the bottom, and 6 Z's on the bottom. 1, 2, 3, 4, 5, 6. Woof. That's a lot of stuff. All right, let's cancel. Well, this is actually kind of nice because my 16s are going to cancel. 16 divided by 16 is 1. X divided by X, X divided by X, X divided by X. My Y's cancel out. My Z's, some of them cancel out. And let's put back together what we have here. So I can see that I have an X on the bottom and all these Z's on the bottom. So X and Z times Z times Z is Z to the 3rd power. But now you can't just leave that as X times Z to the 3rd power because that X and those 3 Z's are on the bottom of that fraction. So we need to keep that fraction bar. But then what goes on the top? Well, what is 16 divided by 16? What is X divided by X and Z divided by Z and Y divided by Y? Those are all 1. So when there's nothing, quote unquote, when you've canceled everything out on the top, it's not 0, it's not nothing. There's still a real life 1 there. That's very, very important. So that final answer is 1 divided by X, Z to the 3rd power. All right, make sure you use these examples to help you out with those practice problems.